The purpose of this series of videos is to enable you to become the person you wish to be while living the life you truly want, no matter how improbable all that may seem now. In a previous talk in this series, I questioned the inborn talent myth, not in the expectation that you would immediately see yourself as potentially being as talented as anyone else, but so that you would begin to doubt the validity of any feelings of inferiority you might have. I then went on to show that even the most talented people who ever lived had to work hard for their achievements, again to plant the seed of doubt about whatever fears you might have that working hard means you lack ability. Those two subjects were the low-hanging fruits of emotional intelligence. We will need to get a little boost from modern research to access more. The cerebrum, the largest part of the human brain, seems to be split down the middle because it is. It consists of two separate hemispheres that communicate with one another across a band of about 200 million nerve fibers called the corpus callosum. The diagram shows that your left brain controls the movements of your right hand, while your right brain controls those of your left hand. That's only part of the story. Your left brain actually controls the movements made on the whole right side of your body, while your right brain controls your bodily movements on your left side. The diagram also shows that the left brain contains patches of neurons that enable you to speak and understand language. Not shown are somewhat corresponding circuits on the right side too, which enable the right side to not only understand language, but contribute greatly behind the scenes to what we say. If we used only our left brains in speaking, our sentences would be as colorless, unemotional, and highly literal as those of Star Trek's Mr. Spock.
On my planet, to rest is to rest, to cease using energy. To me, it is quite illogical to run up and down on green grass using energy instead of saving it. The precise meaning of the word desert is a waterless, barren wasteland. I fail to understand your romantic nostalgia for such a place.
Doesn't surprise me, Mr. Spock. I can't imagine a mirage ever disturbing those mathematically perfect brain waves of yours.
Thank you, Dr. McCoy. I prefer the concrete, the graspable, the provable.
You'd make a splendid computer, Mr. Spock.
That is very kind of you, Captain.
The metaphors we routinely use to make what we say emotionally interesting depend on the right brain. The diagram also shows that we need our left brain to do math. That's true, but as with speech, it would be a mistake to ignore the right brain's contributions. The left brain can train the right brain to do math quite well. If you studied math to the point that it became second nature to you, thank your right brain, which when trained can solve math problems effortlessly, almost on its own. Remember times when you were working on a math problem and your mind went stubbornly blank? Your left brain had gotten stuck, but your right brain continued working unconsciously to come up with a new approach for the left brain to use, an approach that would eventually surface as a bright idea. Remember the times when you gave up as soon as your mind went blank? You failed to solve those problems because you didn't give your right brain a chance to do its thing. Long ago, surgeons hit on the idea of severing the fibers of the corpus callosum as an approach to suppressing epileptic seizures. Not surprisingly, the operations caused some deficits, but not as many as you might think. It turns out that our left hemisphere is the seat of much of what we think of as our conscious self. So split-brain patients seem pretty much the same afterwards. They could talk and understand conversations and continue to make conscious choices. But they did lose conscious control over their left hand, which, as we have seen, was controlled by the now separated right brain. Finding out what goes on in the right hemisphere was a bit difficult because right brain processes are unconscious and the right brain can't speak on its own. But that didn't stop researchers from questioning both left and right hemispheres of split-brain patients with right hemisphere answers coming in the form of left-hand signals the right hemispheres made. The most surprising finding was that our left and right brains are often in conflict with one another, which showed up as left hands of split-brain patients acting contrarily on their own. In his book Of Two Minds, The Revolutionary Science of Dual Brain Psychology, researcher and psychotherapist Frederick Schiffer details many examples of this. One split-brain patient couldn't light up a cigarette with his right hand because his left hand kept snuffing it out. Another split-brain patient had to use his right hand to prevent his left hand from punching his wife. In each case, the patient's left brain was startled by what the right brain did. An even more surprising conflict was found in one patient whose hemispheres were separately asked whether they believed in God.
And what we did was we had to first train the right hemisphere to communicate with us. In fact, the right hemisphere can read simple commands, simple words, simple sentences. And then you ask a question and say, point to a box, yes, no, I don't know. Because it can't talk. The right hemisphere cannot talk. But it can comprehend simple semantics, simple questions. Left hemisphere, of course, can talk. So you can present boxes, yes, no, I don't know. So we asked, for example, are you at Caltech? And the right hemisphere pointed to yes. Are you on the moon? It said no. Okay, so now comes the big question. What if you ask, do you believe in God? So I said, do you believe in God? And the right hemisphere went straight to yes. Right? Asked the same question to the left hemisphere, yes, no, I don't know. It went to no. Right? So here's a human being whose right hemisphere is an atheist, and left hemisphere, on the other hand, believes in God. And this finding should have sent a tsunami through the theological community, but barely produced a ripple, because it raises all kinds of profound theological questions. If this person dies, what happens? Does one hemisphere go to heaven and the other go to hell? I don't know the answer to that.
At first, researchers saw the conflicts as resulting from each of us having two selves, one in the right brain and another in the left. Eventually, they realized that the conflicts arose from differences in the ways the two hemispheres process and respond to information. As I indicated, you already know a lot about left brain capabilities because that hemisphere contributes to many aspects of your conscious life. The left brain is the part of us that makes conscious choices based on rational analyses of the information at hand. It is the source of what we think of as our intellectual capabilities. The right hemisphere is a whole different animal. It has no patience for the details the left brain loves to think about, or the left brain's version of rational thinking. It uses all of the information coming from your senses in arriving at big picture assessments of situations, their causes, and the best ways to deal with them. It does all this with ease and at lightning speed, using unconscious processes that rely on inborn biases. Whatever answer satisfies all of the constraints the biases impose is the answer it goes with. So your brain is made up of a left brain that is good at consciously solving problems by rationally analyzing fine details, but whose focus on details may cause it to lose sight of the big picture implications of the conclusions it reaches. The right brain, by contrast, can quickly arrive at unconscious big picture solutions to life's problems, but it may ignore crucial details in arriving at the conclusions it reaches. So it is not surprising that these two different approaches to decision-making often lead to different conclusions, or different reasons for arriving at the same conclusion. Subjectively, we perceive the conflicts between the two hemispheres as conflicts between our rational mind and our emotions. The right brain cannot speak, read, write, or spell very well on its own, and it has trouble understanding abstract concepts too. But it can talk in a manner that is suited to its holistic outlook, the language of emotions. There is wisdom in considering emotions as multifaceted communications that are too complex to be reduced to strings of words. This is why people often find themselves at a loss to describe how they feel. So when we have something simple to say, we say it with left brain words. When the communication to ourselves and others is too complicated for words, we resort to right brain emotions. Most of the strong emotions you feel come from the right brain. If you don't believe that your left brain has problems expressing emotions, try this simple experiment. Smile into a mirror and really mean it emotionally. Now cover one side of your face with your hand and then the other. When you do that, you find that both sides of your face will seem to smile, but then only the left side of your face, the side under the control of your emotional right brain, will actually exhibit an emotional smile when you look closely. Your left eye will twinkle, and the left side of your face will seem to be genuinely smiling. When you switch so that your left brain's right side is revealed, you will find that your right eye doesn't twinkle with emotion the way the left eye did, and that the rest of your right side of your face is just going through the motions of an unemotional fake smile. Most of us are unconsciously aware that the left side of our face is more emotionally appealing. That's why most people slightly turn the left side of their face to the camera when taking selfies. Let's look at a couple examples of left brain, right brain conflicts in action. Remember the split brain patient whose left hand kept preventing him from smoking a cigarette? Our brains, of course, are connected to our bodies with our right brain's holistic capabilities, enabling it to remain aware of the state of our body's health on a continuing basis. In this case, the patient's right brain possibly sensed that smoking was harming his health, something his left brain was unaware of or was trying to ignore. If the two hemispheres had been connected by the corpus callosum, the right brain would have probably protested by communicating a gut feeling to the effect that the patient shouldn't smoke. Because there was no means of communicating that feeling, the right brain had to resort to direct action. I recently experienced a gut feeling after I had a dishwasher replaced. I noticed the ice maker in our refrigerator stopped making ice right afterwards. Based on its holistic thinking, my right brain immediately concluded that the ice maker stopped because of something the workman did, creating the gut feeling that I should demand that the installer come back to fix the problem he had caused. Possibly to avoid embarrassment if it turned out that my holistic right brain was wrong, my analytical left brain resolved to check whether the details of the situation supported my right brain's hunch. If the right brain was right, then the refrigerator's ice maker stopped making ice because the workman had shut off the refrigerator's water line and forgotten to turn it back on again. Because examining all the water lines in the kitchen would have meant crawling under the sink and fighting my way through a jungle of cleaning products, my left brain settled on a simpler approach. It reasoned that if the refrigerator's water line had become disconnected, then the refrigerator's water dispenser should not work either. But it did. So my holistic right brain's hunch was obviously wrong. The ice maker, not the installer, was the culprit. That the ice maker had stopped working when the new dishwasher was installed was merely an unlikely coincidence. Not only is the left brain emotionally impoverished, it finds it difficult to pick up on the emotions of other people. It is largely deep to the emotional tone of somebody's voice and nearly blind to emotional facial expressions and body language clues. Remember the split-brain patient whose left brain had to stop the patient's right brain from punching his wife. She probably had done or said something emotionally offensive, which was picked up and reacted to by the right brain while the left brain remained clueless. It is mainly because of your right hemisphere that you can tell if somebody is happy, angry, sexually aroused, bored, or skeptical. Through its holistic capabilities, the right hemisphere can also accurately determine what another person feels about what he or she is saying and discern the reason why he or she is saying it from the context of the conversation, all of which are things the detail-oriented and literal left brain has trouble doing. Feeling, intent, attitude, and related emotional states are not only perceived and processed by the right brain also conveys its emotional states to others by adding vocal nuances to the things the left brain says and through facial expressions and body language. The left brain's emotional blindness can be an important source of pathogenic beliefs, to get back to a subject mentioned in the first talk in this series. The children can be traumatized by their parents, siblings, and peers, sometimes inadvertently and sometimes not. Yet when childhood traumatizations are remembered years later, they are often recalled unemotionally as things that happened in the distant past. People are therefore led to the pathogenic belief that the events were much less traumatic than they actually were, and that even if they were traumatic, they happened so long ago that any after effects have surely faded from memory. The first step in recognizing how wrong all this is to understand that we primarily use our left brain when we visualize anything, including our autobiographical memories. That is, we use the part of the brain that is blind to emotion. So childhood traumatizations become shorn of the emotions felt in the past when they are recalled. It is therefore incorrect to conclude that such emotionally expunged memories indicate that emotional trauma was not experienced at the time the remembered events occurred. It is true, generally speaking, that memories do fade over time. It doesn't follow, however, that the same can be said of traumatizations. In his book, Of Two Minds, The Revolutionary Science of Dual Brain Psychology, Friedrich Schiffer offers a case in point. Schiffer devised an experiment in which both brains of a split-brain patient were asked to simultaneously respond to 49 questions by touching pegs lined up in rows behind a curtain, one set of pegs for each hand. Touching the first peg represented the answer none, the second mild, the third moderate, and the last extreme. Most questions were about innocuous things such as how much the patient loved his mother, shopping, movies, eating, sex, work, things like that. And the answers both brains gave were very similar. But 14 other questions were about childhood traumas the patient had experienced at the hands of a group of bullies who picked on him over a period of years when he was a child. Schiffer asked the patient how scared he was of the bullies, how frustrated he was by them, how hopeless they made him feel, how cruel he now felt they were, how much the bullies bothered him today, and how angry he was at the bullies. The right and left brain answers to these questions diverged greatly. His left brain reported both verbally and with his right hand responses that he was not upset anymore about the bullying because what happened was so long ago. But his right brain gave a very different picture. Its answers revealed that his right brain remained very disturbed by what had occurred 30 years earlier. It was as if there was no passage of time as far as the right brain was concerned. The memories and humiliations he experienced were still fresh in his mind. Although this was only one test of one person, the results Schiffer found have been supported by other studies. The after effects of childhood traumas do not fade away with time, as your left brain would suppose. Did you experience childhood traumas that you now either are unaware of or downplay as happening too long ago to affect your life today? If so, there is a way of telling which of your hemispheres remains affected by the traumas. Of course, if both brains were equally disturbed, this test would show nothing, as would be the case if no serious traumas had occurred. It turns out that we can regulate the activity levels of our two brains by varying the amount of light each receives. A hemisphere deprived of light doesn't shut down, but it does become less active than the hemisphere receiving light, and this difference can be just enough to have noticeable effects. Schiffer found that about 60% of his patients noticed a change in optimism when they blocked the light to a particular hemisphere. That is, many patients felt better about themselves and were more optimistic when the more troubled hemisphere was temporarily less active. At times, patients simply felt more at peace. Of course, the changes lasted only as long as the light deprivations continued. Schiffer used the changes in his therapy to convince patients that the pessimism they normally felt was exaggerated, something that they would tend to disbelieve if he merely told them that in so many words. The light deprivations showed the patients in dramatic fashion that a part of them already held a more optimistic outlook. The top of the diagram shows what you need to know to block the light to one hemisphere if you want to duplicate Schiffer's test. The sheets behind the eyeballs at the top of the diagram represent each eye's retina. Notice that each retina is split into two parts, and that light from each eye goes to both hemispheres. So if you wanted to depress the activity of the right hemisphere, say, it wouldn't be enough to cover your left eye. You would also need to cover the inner part of your right eye, too. Try it for yourself. Block the light reaching the right hemisphere for about 30 seconds, and then block the light to the left hemisphere using the same two-hand technique. The right hemispheres of Schiffer's patients were found to be disturbed more often than their left hemispheres. Schiffer developed special glasses for patients who wanted to spend time in their optimistic frames of mind at home. He simply covered workman's goggles with tape. Nowadays, you can buy glasses made to Schiffer's specifications that allow you to block either hemisphere from receiving light using these flaps. These are called New View glasses.